Hello student, this video lecture is prepared for heat transfer subject and I will discuss the unit number 4, that is condensation and boiling. In previous lecture we had discussed how to solve the problem based on correlations of nucleate saturated pool boiling. So this is the exercise number 3. Then we will discuss how to calculate the peak heat flux or critical heat flux in a nucleate pool boiling. So first we will discuss what is the formula for calculation of peak heat flux or critical heat flux for nucleate pool boiling, and then we will solve one problem on these correlations. So wait for 1 minute. So last lecture we have solved this problem which is based on nucleate pool boiling. Then today's lecture we will discuss another correlations for pool boiling, that is known as the critical or peak heat flux in a nucleate pool boiling. So we have already discussed. So I had showed this graph here, Q by A versus delta T. We have already discussed this graph. So segment AB is the natural convection, segment BC is the nucleate boiling. So in this nucleate boiling, this point, that is point C, is called a critical heat flux, and this segment is called a nucleate heat boiling. So if we want to calculate the critical heat flux in the nucleate pool boiling, which is also called a Q by A maximum. So Q by A is nothing but it is a flux. So these flux are maximum for this condition. Okay, and after that the curve is decrease and then increase, but we will design the heat transfer equipment which is used for the boiling up to this point. So it is called a critical heat flux or peak heat flux or Q by A maximum. So how to calculate that? So there is formula is given. So Q by A maximum is equal to pi by 24, this is the constant, multiplied by lambda. So lambda is latent heat enthalpy of vaporization, which is in a joules per kg. So this is the SI unit. Then rho V, that is density of saturated vapor kg per meter cube. So these notations we have already discussed in previous correlations, but here I will again tell these notations. Then you have to multiply by sigma, that is surface tension of liquid vapor interface. So that is in Newton per meter. G, acceleration, gravitational acceleration, which is having SI unit, meter per second square. Then rho L is the density of saturated liquid. So this is the density of liquid. L is stand for liquid, and rho V is the density of saturated vapor in kg per meter cube. So V is stand for vapor, and whole this bracket having the power 1 by 4. So if we put the values of these parameters in this equation and calculate Q by X maximum, so that is called a critical heat flux. So we will discuss one problem. So this problem is given is that estimate or calculate the peak heat flux for the conditions of the previous example. So what are the conditions is given in this example? So these conditions, the properties of water at atmospheric pressure are given, these conditions. So some parameters we are needed in that equation. So use this equation, use this data and calculate the critical heat flux for this condition. So lambda is given is as a 2257 into 10 to the power 3, that means it is in a joules per kg. Then density is, vapor density is mentioned here. Then sigma, that means surface tension, which is multiplied by gravitational constant, that is 9.81. Then into bracket we have to write the density of liquid minus density of vapor, and whole square bracket is having power 1 by 4, and this vapor density is having power 1 by 2, and whole thing we have to multiply by pi by 24. So this is the, we can say, constant for this equation. So after calculation we get this value 1105655 watt per meter square. So it is also written in the form of 1.105 into 10 to the power 6 watt per meter square. So in this way we can calculate the critical heat flux, that is this value, for the given conditions. So these are the given conditions. So for these conditions we are having critical heat flux is as 1.105 into 10 to the power 6 watt per meter square. Okay. Then we will discuss the conclusion point. So in this fourth chapter, what topics or what points we have covered. So I will show that first content. So we will discuss shortly. So in this chapter we have already discussed what is meant by condensation. Then there are two types of a condensation: dropwise and filmwise condensation. So these definitions of these also we have discussed. Then we compare between dropwise or filmwise condensation. Then we have two correlations for filmwise condensation, because the filmwise condensation is used in industry. Dropwise condensation is not used in a chemical industry. So we have some equations for vertical and horizontal surface, and then how to calculate Q and how to calculate the m dot. So these are the two examples we have already discussed in this section, correlation. Then we had discussed the effect of non-condensable gases. Then the second part of this chapter is the boiling. So how the boiling process is taking place, what are the applications of boiling, distillation, evaporation, boilers, steam generation. So these are the applications. Then we have discussed pool boiling. So what is meant by pool boiling? What are the types of pool boiling, that is subcooled boiling, saturated pool boiling, etc. Then we had discussed the pool boiling curve. So that is Q by A versus delta T graph. Then there are segments of that graphs is natural convection, nucleate boiling, transition boiling, and film boiling. And then we had discussed what are the correlations for that nucleate pool boiling and how to calculate the critical heat flux. So these are the points we had discussed in a unit number 4. So in this way this chapter or this unit is completed. Then I had posted one tutorial, which is tutorial number 4, and the name of the topic is the condensation and boiling. So the first question is define the terms. So you have to define the condensation, filmwise condensation, dropwise condensation, and what is meant by pool boiling. So this is the first question. Then in second question we have to compare the dropwise condensation and filmwise condensation. So this part we had already discussed in a previous lectures. Then you have to write what is the effect of non-condensable gases on the condensation. So this point I have already discussed. So you can write the answer of this point. question. Then explain the saturated pool boiling and subcooled boiling. So boiling is having these two types, saturated and saturated pool boiling and subcooled pool boiling. So this we have already discussed. Then next question is question number 5. We have to explain that pool boiling curve or pool boiling plot by using Q by A. That means heat flux versus delta T. So delta T is nothing but TW minus TS. So you have to write the answer of this question by plotting the graph Q by A versus delta T and write what is happening in the segment AB, BC, then CD and then DE segment. And in the last part, explain the effect of surface tension on bubble formation of the boiling. So we have already discussed that the bubble formation is important in a boiling process. So surface tension is effect on this bubble formation. So we have that diagrams, that is when the surface tension is having higher, then how the bubble is formed, when the surface tension is intermediate and when the surface tension is low. We have already discussed this answer in the discussion of this lecture. So complete this assignment in a time and submit in a Google Classroom. So here I have declared that this chapter number 4, that is condensation and boiling, is over. And write these assignments in your notebook and scan and upload in our heat transfer Google Classroom. So thank you.